Hello everyone. Today I will be discussing about the plasma membrane and its relationship with the cholesterol. As we all know that cholesterol actually inside the cell is stored at the level of plasma membrane. Why so? There are many benefits, pros and cons associated with this cholesterol and the plasma membrane. What happens that this cholesterol is a wonder molecule for the plasma membrane. First of all, if you see that here in the cholesterol part, a OH group is actually hanging over, and the remaining entire this part, apart from this hydroxyl group, entire this part is nothing but carbon and hydrogen. And what does it mean? That it is a long chain along with the cycles of hydrocarbons. So it makes it totally hydrophobic part at one end, and there is a small hydrophilic part. Now let me tell you about the hydrophobic and hydrophilic parts. Hydrophobic parts are those parts, or hydrophobic molecules are those molecules which actually keep themselves away from water. Means what? They are not willing to come with interaction with water, or you may call it as they are getting afraid of water. But the hydrophilic parts are those, or hydrophilic molecules are those which have an affinity for water. So in this way, it is acting as an amphipathic molecule, means it has both characters, hydrophobic as well as hydrophilic. Now what happens, if you see with some little detail, that in the plasma membrane itself has two layers. This is one layer and this is another layer. In each layer you will find, you could see that these are tiny ball like structures. These are hydrophilic parts of a fatty acid, right? Actually the membrane lipid. And these yellow color long structures, these are actually the area where it is blinking, right? These are actually hydrophobic tails. Now you can very well imagine that it has both parts. One end is hydrophobic and one end is hydrophilic. Now what happens, if you consider the cell, it is almost 70 to 80% containing water. Means without water you cannot imagine a living cell. At the same time, the boundary of the membrane, boundary of the cell is actually having both kind of properties, hydrophobic and hydrophilic. Now it's a challenge for the membrane to interact with water part, aqueous medium, as well as hide its hydrophobic parts. So for that purpose, what it has done, it has made itself in such a way that either it is extracellular or it is intracellular, it will be facing the water with its hydrophilic part, and in between the two hydrophilic zones, a hydrophobic part would be embedded. In this way, what is it doing? It is avoiding direct contact of water with it. So in this way it is stabilized. Now see this cholesterol. This is also having hydrophobic and a hydrophilic part. Now what happens, the importance of cholesterol here is that it helps to maintain the membrane fluidity. Now suppose that it is quite cold, temperature is below zero. Now what happens, as the temperature falls, the intermolecular forces, the freedom of the molecules to move from one end to another keeps on ceasing. Means what? They are losing their energy to do that. Their free movement keeps on going down and down and down. So a time may come when you will find that the lipid bilayer is freezed, right? So this is the condition, this is the state when the cell is going to die, because if the membrane fluidity is lost, everything is lost. As long as this boundary is flexible, is able to transport molecules across, the cell is alive. cell is able to exchange its waste with the outside as well as absorbing the nutrients from outside to inside. Now, if the boundary is frozen, then neither it can put out its waste to outside nor it can absorb its required molecules to inner side. So this is virtually a condition when the cell will die. So to avoid this condition, how this cholesterol is coming as a help, you will find that this OH group is putting a hindrance in proper what to be said, coming close of the molecules of the lipid bilayer together. Means what? Every molecule of this lipid are very close at low temperature, but this hydroxyl group of the cholesterol is putting a kind of kink. That is why it is not allowing the molecules of one layer or the other layer to come very close to each other, and this is the reason why in the low temperature as well the membrane is able to maintain its fluidity. Now come down to the higher temperature. What happens? That high temperature the molecular energy goes up. Now if it is the case, then what will happen? The molecules of this lipid, right, that are making the integral part of this membrane would be so much so in full of energy that they will try to fly off from each other, and the integrity of the membrane will go down. Again there is a problem, again there is an issue that at high temperature also this membrane integrity cannot be maintained. Now again this cholesterol is coming as a savior, is rescuer at this point. What happens when this high temperature comes? I mean to say the temperature or the heat is exposed to the plasma membrane. First of all, what happens? Due to, you can understand from this structure, this diagram, that the molecules of this end, this is, suppose that it is extracellular phase and this is intracellular phase. So the molecules which are present at this layer on the extracellular side of this plasma membrane cannot freely come towards intracellular side of the plasma membrane, because if they have to come from this end to this end, they have to travel all along these two layers of the hydrophobic part, and that is an energy intensive action. Now what happens when the temperature rises? The first thing that will happen, that these cholesterol molecules which if are present on the top surface would take up this energy and would try to cross this bilayer, which was an energy intensive state, to come to the inner surface of the bilayer. So in this way it is utilizing energy and moving from one end to another. Likewise, the same thing would be done by the cholesterol molecules which are placed at this end, the inner end. They will also absorb energy and will try to cross over this boundary and will try to move to the upper surface. So in this way they are the first one uptaker of this energy, this heat exposure. So in this way they are actually resisting any kind of change in the fluid structure of the plasma membrane. So this is how this cholesterol is helping this plasma membrane to maintain its fluidity. So that's all for this lecture.